Okay, so you want to be a senior software engineer, right?
Mhm.
And you know that means nailing those system design interviews.
Yeah, you've got to go deep. Show them you can break down a complex system like a pro. And one of the most crucial skills there, deciding those microservice boundaries.
That's where it gets tricky. It's not just about knowing what microservices are, it's about knowing how to use them strategically. So today, we're going deep on that.
We're going to unpack the core ideas that separate a solid microservice architecture from a messy one, the stuff that makes interviewers sit up and take notice.
We'll talk about concepts that have been shaping modular and distributed systems forever. These are the fundamentals that underpin really effective microservice design. We want to give you that edge in your interviews.
Because these principles, they're not just theory. They've been proven to build systems that can scale and that won't break down the minute things change.
Right. So to make sure we cover everything, we're going to focus on three key pillars: information, hiding, cohesion, and coupling. Those are the big three for getting microservice boundaries right.
And they're all connected, so understanding how they work together is really key.
Okay, so let's start with information hiding. Sounds
Yeah.
kind of secretive.
It is, in a way. It's about designing each service to hide its internal workings. Like, think about when you use a well-designed library or a module. You interact with its public interface, but you don't need to know exactly how it works under the hood.
Oh yeah, I get that. It's like using a fancy coffee machine. You know how to make your latte, but you don't need to understand the plumbing and the heating elements and all that.
Exactly. So with microservices, it's the same idea. The internal complexity of a service, hidden. Only the essential functionality is exposed through a well-defined interface. And that leads to some huge advantages.
Like what? Speed things up.
Definitely. Development becomes much faster. Teams can work on separate services independently without getting bogged down in the details of other services.
So it's like giving each team their own sandbox to play in, less stepping on each other's toes.
Right. And it also makes the whole system way easier to understand. If each microservice represents a single business capability and it's self-contained, you don't need to wrap your head around the whole thing at once.
That's so true. It's way less intimidating for new developers coming onto a project too. They can focus on one service at a time instead of facing this massive, overwhelming code base.
Absolutely. It simplifies onboarding, makes debugging easier, and maintenance becomes less of a headache.
So information hiding makes things easier to understand, easier to develop. What about adapting to change? How does it help there?
Well, because each service is independent, you can change them and deploy them without affecting other parts of the system. No more huge, scary releases where everything has to be coordinated perfectly.
You mean like the old days of monolithic applications where one small change could break everything?
Exactly. With well-designed microservices, you can be much more agile and respond to new business needs quickly. You can even combine existing services to create new functionality, like building with Lego blocks.
This idea of modularity, it's not really new, is it?
Nope. The principles behind it have been around in software design for a long time. Microservices are like a modern take on those classic ideas, adapted for today's complex distributed systems.
And APIs are a perfect example of information hiding in action, right?
Exactly. A well-designed API acts as that clear boundary between services. It tells you what the service can do without revealing how it does it. You see the inputs and outputs, but the internal workings are hidden.
So you can completely change the database structure or the algorithms inside a service, but as long as the API stays the same.
The other services that use it won't even notice. They just keep interacting with it through the API.
I remember reading this quote about modularity. The connections between modules are the assumptions which the modules make about each other. How does that apply to microservices?
That quote really nails it. Every time two services interact, they're making assumptions about each other. Those assumptions create dependencies. And the more assumptions, the tighter those dependencies become.
So it's about keeping those assumptions to a minimum.
Exactly. The fewer assumptions, the looser the coupling between services. And that's what we want. Services that can change and evolve independently without constantly breaking each other.
And well-defined interfaces help at that, right?
Absolutely. Clear contracts help to minimize those implicit dependencies. When everyone knows exactly what to expect from each service, there's less chance of unexpected side effects.
So if one team makes a change to their service, they can be pretty confident that they're not going to break another team's service.
Exactly. And that's what makes independent deployment possible. You can deploy a change to one service without having to coordinate a massive release with other teams, and that leads to faster development cycles and less risk.
Okay, so we've talked about information hiding.
Yeah.
It sets the stage for creating these independent units. Let's move on to our next principle, cohesion.
Right. The classic definition is the code that changes together stays together.
That's catchy. But how does it apply to designing microservices?
It means we should group functionality within a service based on how closely related it is. If two pieces of functionality always change together, they probably belong in the same service.
Can you give me an example?
Sure. Think about an online store. You have functionality for managing customer profiles and functionality for managing shopping carts. Those are probably separate microservices because changes to one usually don't affect the other.
So like changing a customer's address wouldn't affect how the shopping cart calculates discounts.
Exactly. Keeping them separate keeps things clean and simple.
So high cohesion means grouping things that naturally belong together. What's the advantage of that?
Well, it makes services easier to understand and maintain. It also reduces the risk of introducing bugs because changes are more localized.
What about the opposite? What happens if you have low cohesion?
Then you end up with a service that's doing too many unrelated things. It becomes this big, messy blob that's hard to understand and even harder to change without breaking something.
Sounds like a recipe for disaster.
Yeah, low cohesion leads to slower development, more bugs, and just a general feeling of pain for everyone involved.
I'm starting to see how all these concepts are connected. So let's move on to our third principle, coupling. We want loose coupling between our services, right?
Absolutely. Loose coupling means that services can change independently without affecting each other. It's what makes microservices truly agile.
What are some things that can cause tight coupling?
The biggest culprit is sharing a database between services. If multiple services are directly accessing the same database, a change to one service's data model can break all the others.
So each service should ideally have its own database.
Exactly. And if other services need data from that database, they should get it through an API, not by directly querying the database.
That makes sense. So what else can cause tight coupling?
Another thing to watch out for is overly complex or brittle communication between services. If services are tightly integrated or rely on knowing too much about each other's internals, then any change can have a ripple effect.
So how do we avoid that?
By using well-defined and stable contracts for communication, things like APIs using REST or GraphQL or message queues for asynchronous communication.
What makes a good contract?
It should be clear, comprehensive, and as stable as possible. It should focus on what the service does, not how it does it. And any changes should be backward compatible whenever possible.
Our materials also mention something called chatty communication. What's that?
It's when a service makes lots of small requests to another service to do a simple task. Each request might seem harmless, but all those back and forth calls can create a performance bottleneck and make the service less resilient.
So even if the data being exchanged is simple, too many calls can create a tight coupling.
Exactly. And it can lead to performance problems and make the system less reliable.
So it's not just about what's being exchanged, but also how often those exchanges happen.
Right. It's about finding the right balance between minimizing the number of calls and keeping the data exchange loosely coupled.
Okay, so we've talked about information, hiding, cohesion, and coupling. How do these all fit together?
Well, cohesion and coupling are kind of two sides of the same coin. High cohesion usually leads to loose coupling. If you group related functionality together within a service, it reduces the need for that service to talk to other services.
And low cohesion leads to tight coupling because unrelated things are mixed together.
Exactly. And there's this law in software engineering called Constantine's law that sums it up. A structure is stable if cohesion is strong and coupling is low.
So the stability of a system depends on how well these principles are applied.
Absolutely. The more stable the system, the easier it is to change and evolve without breaking things. And that's what makes microservices so powerful. They allow you to build systems that can adapt to changing requirements.
But that stability also relies on having stable APIs and contracts, right?
Absolutely. If APIs are constantly changing in backward incompatible ways, it defeats the whole purpose of having independent services. You end up back in the world of tightly coupled monoliths.
So the goal is to find the sweet spot between strong cohesion within services and loose coupling between them.
Exactly. And the right balance will depend on the specific needs of each system. There's no one-size-fits-all answer.
And it's not like these decisions are set in stone, right?
Nope. As systems evolve, you might need to revisit those boundaries and adjust them. That's a sign of a healthy architecture, one that can adapt to change.
So for anyone preparing for a senior software engineer interview, Being able to talk about these principles and how to apply them is crucial.
Absolutely. Interviewers want to see that you understand these core concepts and can use them to make smart design decisions.
It's about showing that you can think critically about system architecture and go beyond just the basics of microservices.
Exactly. It's about demonstrating that you can build systems that are scalable, maintainable, and resilient to change.
So as you continue your interview prep, think about how you would apply these principles in a real-world scenario.
Hmm.
How would you define those microservice boundaries? What challenges might you face, and how would you overcome them?
Being able to connect those concepts to practical situations is what will set you apart from other candidates.
It's about showing that you're not just memorizing definitions, but that you can actually use this knowledge to build great software.
Exactly. And good luck with your interviews.
And thanks for joining us for this deep dive. We'll see you next time.